You're welcome to class today, where we are going to talk about another application of what we already know in solving three-set problems. So let us consider this problem. In a college survey, 18 students offer biology, 25 students offer mathematics, while 23 offer government. 9 offers both biology and mathematics, while 10 offers mathematics and government, and 6 offers biology and government. The survey was carried out on 50 students altogether, and 5 of them do not offer any of the 3 subjects. The first question is, how many students offer all the 3 subjects? That's the first thing. The second one is, how many students offer only mathematics? The third one, how many students offer government but not mathematics? Then the fourth one is biology and government but not mathematics. These are the problems you are faced with. I'm going to show you how to tackle them because they are very, very easy. So let us go to the solution of this problem. Like always, the first thing is to bring out all our parameters. So we have the solution to this problem. We're given that the universal set, that is the total number of students in question, is 50. So we have U equals 50 students. So out of these 50 students, the number of students that offer biology is equal to 18, while the number of students that offer mathematics is equal to 25, and the number of students that offer government is 23. The additional information here is that 9 students offer both biology and mathematics. So number of biology intersection mathematics will give us 9. While we're also told that the number of students that offer both government and mathematics equals 10. So government and mathematics equals 10. Also, we have that the number of students that offer both biology and government is equal to 6. Of course, we have the number of students that offer all the subjects, which is number of biology intersection government intersection mathematics. We're not given from the question, so we have to use X to denote it. Now, before we draw the Venn diagram, let us calculate the number of students that offer all the 3 subjects. Using the formula, we have U is equal to the number of biology plus the number of mathematics plus the number of government minus the intersection between any 2 subjects. So minus government and mathematics, then minus biology and government, then plus the intersection of the 3. We have biology intersection government intersection mathematics. So since this has been done, we have to impute our parameters into the problem so that we can now solve for the unknown variables. But wait, we're told that 5 of them do not offer any of the 3 subjects. From our previous lectures, I told you that when we have the number of probably students or customers, or depending on what question we are given, that are not part of the problem at all. In fact, what is happening in the problem does not concern them. So how do we represent them? We have to subtract them from the universal set so as to get the original universal set. And how do we do that? Let us denote them with y. So we have minus y over here. Is that okay? So if I decide to substitute my values inside the equation, I have 50 minus 5 equals 18 plus 25 plus 23 minus 9 minus 10 minus 6 plus x. And if I do my normal arithmetic, I have that this is 45, which is equal to 41 plus x. Now, subtract 41 from both sides to make sure that x stands alone. If I do that, I have minus 41 minus 41. Of course, these will cancel out this, and x is now standing alone. So I have x is equal to 4. That is, the number of students that offer the 3 subjects is 4. Okay, so let us move further to drawing the Venn diagram, since we have all the parameters at our fingertip. So let us represent these as the universal set, and these as the first one, the first set, this as the second one, and this as the third one. So this area shows the intersection between the 3 of them. So we have this as 4. Of course, let us call this biology, let us call this mathematics, and let's call this government. Remember, we have 5 of them who do not offer any of the courses. So we have y is equal to 5. Is that okay? So the mathematics, for mathematics we have 25 of them. For biology we have 18 of them, while for government we have 23 of them. So since this is done, the number of students that offer both biology and mathematics, which is equal to, from the question, which is seen as 9 minus x, of course 9 minus 4, which is 5, therefore 5 should be here. And for mathematics and government, we have that we have 10 minus x, which is equal to 10 minus 4, which is 6. So we have 6 over here. And for biology and government, we have 6 minus x, which is equal to 6 minus 4. And 6 minus 4 gives me 2. So we've been able to identify some of the parameters that we are given. So let's go straight to solving the problem. We've solved the first problem by indicating the number of students that offer the 3 subjects. Now let us find the number of students that offer only mathematics. Can this be done? Of course. We have all our parameters at our fingertips. So to do that, we have to consider the circle that has mathematics. So doing this, we have that mathematics alone is given by this circle. So since we have this, we know that this partition over here, we have this partition, we have this partition, we also have this partition. And of course, this partition is 5, this is 4, and this is 6. The total number of students offering mathematics alone, mathematics in general, M equals 25. So mathematics alone, this will give us maths alone. How do we get maths alone? It's simply subtracting all other values from the general or the total number of students offering mathematics. So let us consider this. Maths alone will give us 25 minus 5 minus 4 minus 6. Of course, if you subtract all of them together, you are definitely going to get 10. So 10 students offer mathematics alone. Okay, let us go to the third question. We are asked to find the number of students that offer government but not mathematics. Please listen to that very well. Government but not mathematics. I'm going to show you from the Venn diagram. Remember, we said in our introductory lesson that Venn diagram is very, very important because it gives us the pictorial view of everything we are talking about, and you know for sure that if you have a picture of what you're talking about, you know what you're talking about. So they asked us to find government but not mathematics. That is, everything that concerns government insofar as mathematics is not there. Is that okay? And which area are we talking about? So if we look at the Venn diagram very, very well, government has, let me show you, government has all these parts. Government has all these parts. But we need all the parts with government without the mathematics. So mathematics having this part should not be included. Mathematics having this part should not be included. Therefore, the area we need are, let me show you the area we are considering. The area we are considering are just these parts. Are just these parts. Look carefully at these parts. It looks like something like a crescent. This is just what we are looking for. But remember, we can't find these. We can't find these. We can't. Because we don't know what this area is. We only have that this is 2. We don't know what this part is. So that is our first aim. And this part can be solved from the total number of students offering government. So let us do that first before we solve for what we're actually looking for. So for government only, we are going to start from government. Government only. Government only has this area. So we have this, we have this, and we have this. This area is 2, this is 4, and this is 6. Of course, we know that G is equal to 23. This is the area we are looking for. Is that okay? So if you have this, then we can now solve for government but not mathematics. We need those students offering only government without mathematics. So it could be government and biology. Do you understand? And it could be government only. Do you get it now? So how do we do that? Is to find our government only. Government only, let's say G only, will be equal to 23 minus 2 minus 4 minus 6. That gives us 23 minus 12, which will give us 11 students. So 11 students offer government only. But this is not what we are asked to find. What we are asked to find is actually this area over here. We are asked to find this area. So this is what we are asked to find. Is that okay? And these, of course, you know that these has both 2, it has 2 as well as 11. Therefore, for government but not mathematics, government G but not M will give us 2 plus 11. Of course, this will give us 13 students. So 13 students offer government but not mathematics. And the last question here, before we wrap it up on this lecture, is to find the number of students that offer biology and government, but not mathematics. Biology and government, but not mathematics. What this is just asking us to find is the number of students that offer biology and government together alone. Is that okay? And from our Venn diagram, okay, this is the fourth question. From our Venn diagram, you already know that, okay, this is it. You already know that this area covers for those offering biology and government. Is that okay? And we already know that this area has 2. Therefore, but for biology and government, but not mathematics, we have 2 students. With this, we've come to the end of this class on the 3 set problems. I am very, very convinced by now you can solve any problem as regards set theory.